Good day everyone and welcome to our math class. Check 05 Mathematics in Modern World. Next slide. Today we will be discussing about the hypothesis. In statistics, a hypothesis is a claim or statement about the property of a population. A hypothesis test or test of significance is a standard procedure for testing a claim about the property of a population. It is a testable statement about the relationship between two or more variables or proposed explanation for some observed phenomena. It is a proposition made as a basis for reasoning without any assumption of its truth.
Now, let's proceed to the next slide. Let's define together. T-test. It is a statistical test that's used when comparing the means of two groups or samples. It is used in hypothesis testing to determine whether a process actually has an effect on the population of interest, or whether two groups are different from one another. Next, one-tailed test. A one-tailed test results from an alternative hypothesis which specifies a direction. So, paano malalaman if a test is right or left direction? So, left-tailed if the critical region is in the negative direction on the number line, and right-tailed if the critical region is in the positive direction. Last, two-tailed test. A two-tailed test in statistics is a method in which the critical area of a distribution is two-sided, and it is used to test whether a sample is greater than or less than a certain range of values. Next.
Null and alternative hypothesis. Null and alternative hypotheses are used in statistical hypothesis testing. The null hypothesis of a test always predicts no effect or no relationship between variables. Ito yung status quo or yung wala or yung equal significant relationship. While in alternative hypothesis naman, states your research prediction of an effect or relationship. So kapag na-reject si null, automatic alternative hypothesis yung ating i-accept. Next is level of significance. The level of significance is the measurement of the statistical significance. It defines whether the null hypothesis is assumed to be accepted or rejected. It is expected to identify the result is statistically significant for the null hypothesis to be false or rejected. Dito malalaman if the null hypothesis lies on the rejection or non-rejection region. Next, critical value. A critical value is a point on the distribution of the test statistics under the null hypothesis that defines a set of values that calls for rejecting the null hypothesis. Dito natin masasabi if we will reject the null hypothesis. Lastly, test statistics. A test statistics is a number calculated by a statistical test. It describes how far your observed data is from the null hypothesis or no relationship between variables or no difference among sample groups. Pinapakita nito kung gaano kalayo ang iyong naobserbahang data mula sa null hypothesis na walang kaugnayan sa pagitan ng mga variables. Next.
Steps in hypothesis testing. Step 1 is to state the hypothesis and identify the claim. Next is the level of significance and compute the degrees of freedom. Step 3 is to compute the t-critical value. Step 4 is to compute the test value. Step 5 is the decision rule, and the last step, step 6, is the conclusion. Next slide. Let's now proceed to our seat work. Next. We have 3 problems and let's try solving them starting with problem number 1. Next. To be presented by Glaire Rochelle Mago, Franz Yvette Espolier, Raisa May Alvarez, and Grace Joy V. Laguador.
Good day. We're going to discuss the question number 1.
A
an aid for improving employees' working habits, 8 employees were randomly selected to attend a seminar workshop on the importance of work. The table shows the number of workloads done per week before and after the seminar workshop. At 0.05, did attending the seminar workshop increase the performance level of employees? And ang gagamitin po natin para sa problem number 1 is the paired t-test.
So, step 1, state the hypothesis. Null hypothesis, population mean A is equal to population mean B. The performance level after the seminar workshop is equal to the performance level before the seminar workshop. Null hypothesis, population mean A is greater than population mean B. The performance level after the seminar workshop increased before the seminar workshop.
Step 2, level of significance is alpha equals 0.05. Degrees of the freedom is n minus 1 equals 8. 8 minus 1 equals 7. Next.
Step 3. Compute the t-critical value. Our t-critical value is 1.895 and we will use one tail test because the alternative hypothesis is directional. And next po. And in step number 4, the table, nandito po yung mga data sa pagkuha ng difference. So, as you can see in the third column, sa pagkuha po nito, ima-minus po natin ang second column sa first column. Then, sa pagkuha naman po ng fourth column, ito naman po ay squared lang po ng third column. Next po. Ito naman po ang gagamitin natin sa pagkuha ng mean of difference, standard deviation, and the t-value. So, we have the mean of difference, which is 2, then the standard deviation, which is 2.88, and lastly, the t-value is 1.964.
I'm Larcia Mago and I will discuss the step 5 and step 6. Step 5, decision rule. As you can see in the graph, we reject the null hypothesis because the absolute value of the calculated t-statistic 1.964 is larger than the critical value 1.895. So kapag mas malaki ang t-statistic kaysa sa critical value, reject the null hypothesis. Pero kapag mas malaki ang critical value kaysa sa t-statistic, we fail to reject the null hypothesis. Next. Step 6, the conclusion. Through the graph saka sa mga computation, we conclude that there is enough evidence to support the claim that the performance level of the employees after the seminar workshop increased than before the seminar workshop. Next.
We will now proceed to our problem number 2, to be presented by Mary Grace S. Dapol, Bernadette G. Cabalsa, Mary Joy Deso Asido, and Ina Marie Aguirre.
Problem number 2. A rural bank is studying the relationship between the mean account balance for individual accounts and the number of transactions per month. Find the coefficient of correlation. Determine at 0.1 significance level whether the correlation is not equal to 0. But first, we are going to determine what is correlation coefficient. Correlation coefficient is a statistical measure of the strength of the relationship between two variables. Relative movement, the values range from negative 1.0 to 1.0. A calculated number greater than 1.0 or less than negative 1.0 indicates that the correlation measurement was incorrect. And here are the sample of 8 accounts of mean balance in 1,000 pesos and number of transactions. And now Mary Grace Dapol will proceed to the step-by-step procedure.
Step 1 is state the hypothesis. Analyze the question to create a hypothesis. In the question, it refers to the correlation between the two variables so that analyze the question to create a hypothesis. In the question, it refers to the correlation between two variables, so that the null hypothesis is P equals 0. There is no significant relationship between the mean account balance for individual accounts and the number of transactions per month. Then step 2. Level of significance is given in the problem, which is 0.01. To find degree of freedom, get the number of sample, which is 8, then minus 2 equals 6. Here is Merijoy de Soacido to continue the discussion.
Step 3. Computing correlation coefficient. So, getting correlation coefficient, R or P, value to identify if the variables are strong or weak, have a strong or weak relation. So, in order to do that, Ms. Cabalsa, pwede ka po bang mag-present ng Excel? Thank you. So, in order to do that, follow these steps. Number 1 is select data. Yes. Okay, then click the data analysis button on the right side. Then find the correlation. Then click OK. Then select the sample mean balance and the sample number of transactions inside the box. Then check the first label in the first row. Okay, thank you. Then input the outrage. Click the cell kahit ano. Okay, then click OK. So, ang lumabas na value of correlation coefficient is 0.033593936. And next, Bernadette Cabalsa is going to discuss the step 4.
Step 4. And now our group will determine the t-test for significance of correlation coefficient. And the formula is T is equal to sample correlation coefficient square root of sample correlation coefficient minus 2 divided by 1 minus sample correlation coefficient squared. 0.0336 square root of 8 minus 2 divided by 1 minus 0.0336 squared. 0.0336 square root of 6 divided by 1 minus 0.0011. 0.0336 square root of 6 divided by 0.9989. And then 0.0336 times square root of 6.0066. 0.0336 times 2.4508 is equal to 0.0823486. So the t-test value for significance of correlation coefficient is 0.0823468 or 0.0823. And Ina Marie Aguirre will going to discuss the step 5 and step 6.
So let's now proceed to step 5, decision rule. Reject the null if t critical value is greater than or equal to 3.707. Otherwise, fail to reject the null. Next po. So based on our decision rule, our decision is since our t critical value is equals to 0.0823 is greater than or not equal to 3.707, we fail to reject null. So to be able to write our conclusion, we have this table stated the critical value and its equal interpretation. Lastly, we have our step 6, which is the conclusion. based on the table, the p-value we get is very weak. So the correlation coefficient is not significant. Thus, there is sufficient evidence to support the claim that they are very weak linear relationship between the mean balance and the number of transactions. Next po.
Let's now proceed to our last problem, problem 3, to be presented by Joyce Francis Agtay, Renat Jasmine of Valencia, Daphne Shane Lucero, and Catherine C. Di Castro.
Hi, I am Renette, and we are going to proceed in the last problem. Problem number 3. A budget head for MMS Sales Inc. would like to compare the daily travel expenses in pesos for the sales staff and audit staff. He collected the following sample information. At 1% level of significance, can we conclude that the mean daily expenses of the sales staffs are greater than the audit staffs? In problem number 3, we use two-tailed test. But first, we need to find out why we need to use two-tailed test. In problem number 3, we need to compare the daily travel expenses for the sales staff and audit staff. If you want to determine the difference, we need to use two-tailed test.
Here are the data of sample 1 and sample 2. Hi, my name is Catherine Di Castro. For step 1, we need to state the hypothesis and identify the claim. Null hypothesis. Population mean 1 is greater than the population mean 2. The mean daily expenses of sales staff are greater than the audit staff. Null hypothesis 1, population mean 1 is less than or equal the population mean 2. The mean daily expenses of sales staff are less than or equal to the audit staff. The hypothesis will be there is no significant budget compare the daily travel expenses for the sales staff and the audit staff. And the alternative hypothesis will be there is significant budget compare the daily travel expenses for the sales staff and audit staff by MSS Sale Incorporated. And for the step 2, the levels of significance is A equals 0.01.
The critical value is 2.977.
10 plus
In
2
order
equals
to determine
22.
the
To get the
critical
level of
value, we
significance,
use two
we need
sample
to
t-tests.
convert the
We also assume
percent of
that it is an equal
decimal
variance.
Step
1
4. Getting the test
percent
value.
is equal
In order
to
to get the test
0.01.
value, we first need to find the mean sample, standard deviation, and the sample size. Mean of the sample 1 or the sales staff is equals to 151.82. We get it from the data analysis tool of Excel using the t-test assuming unequal variances, while the mean of the sample audit staff is equals to 108.33. The standard deviation of sample 1 is 32.084, and the standard deviation of sample 2 is equal to 39.613. We get the standard deviation of each sample by using Excel. We first get the variance of each sample by the equal var s command and selecting the samples. Then we proceed to get the standard deviation by the command equal sqrt and selecting the value of the variance we got. And the n, or the sample size, n sub 1 is 12 because the given problem has 12 sales staff samples, and n sub 2 is 10 for the audit staff. After that, we can proceed in getting the test value by using the formula. T is equals to sample mean 1 minus sample mean 2 minus the difference of population mean 1 and the population mean 2, divided by the square root of n sub 1 minus 1 times standard deviation 1 squared, added to the product of n sub 2 minus 1 times standard deviation 2 squared, divided by n sub 1 plus n sub 2 minus 2 times the square root of 1 over n sub 1 plus 1 over n sub 2. Then we perform the formula. 151.82 minus 108.33 minus 147 minus 110.5 divided by the square root of 12 minus 1 times 32.084 squared plus 10 minus 1 multiplied to 39.613 squared over 12 plus 10 minus 2 times the square root of 1 over 12 plus 1 over 10. We get the value of 0.397. Our test value is 0.397.
On our step 5, which is the decision rule, the test statistics is 0.397 and the critical value is 2.977, and based on the two values, it clearly states that the test statistics 0.397 is less than the critical value 2.977. So it means we failed to reject the null hypothesis. In conclusion, there is enough evidence to support the claim that the mean daily expenses of the sales staffs are greater than the audit staffs.
And that would be all. Thank you for listening.